Anshul Chopra from Microsoft. Mr. Anshul Chopra is working within Microsoft's Customer Success Division. He is focused on driving digital transformation initiatives for Microsoft's customers, particularly the telco and retail industry. A software developer by background, he provides architectural guidance on the solution and applications which are hosted on Microsoft Azure Cloud. He works with CXO Suite to drive IT strategy and roadmaps for the customers aligned with their business objectives. So I welcome you, sir. I would like to tell you all that Mr. Anshul Chopra has joined with us right now from Melbourne, Australia. So I welcome you, sir, in this session.
Thank you so much. Glad to be here.
Okay. It's over to you now, sir.
Thank you so much. And thanks for the lovely introduction. Hi, everyone. My name is Anshul. I currently work in Customer Success Division within Microsoft, where my role is mainly working with some of the largest industries in telco, healthcare, manufacturing, and driving digital transformation within those businesses. I work closely with Microsoft Engineering, Microsoft Research Labs, and also some of our sales and business teams to see what business problems we can solve working with customers. I've been focusing a lot lately on telco and retail industry in the past. And today I'm going to talk about what are the different AI services Microsoft provides for you to build your solutions and solve your business problems. If you go to any of your customers, you would usually have a lot of issues around how they can accelerate innovation or solve some of the operational challenges. And that's what I'm going to talk about. The way I've structured the presentation deck, which I'll share in a moment, I'll talk about background on Microsoft Azure AI and some of the cognitive services which we use. These are the services, again, the AI services. And then I'll touch briefly on the healthcare part of it, how we are focusing on healthcare across the world. And on the last, I'll touch a little bit on the responsible AI part, how we think about AI is good, but whether AI needs to be regulated as well. So let me share my screen and then we'll go from there. Okay, I hope everyone can see my screen.
Yes, sir, it is visible, very much visible.
Thank you. All right, I've already introduced myself, who I am, and if you would like to stay in touch, feel free to ping me on LinkedIn, and happy to connect or answer any of your questions on it. So everyone knows what Microsoft does and what Microsoft provides. So what I've done here is given you a brief overview of what different services are available through Microsoft. These are different products which we sell in the market. The most common one is the Microsoft 365, often called as Office 365. It's the PowerPoint, the Word, the Excel document you use. And on the top, you can see we have Xbox Gaming, we have Dynamics 365. Dynamics 365 is another cloud which is focused on providing enterprise resource planning softwares. It's similar to what you would get from SAP software or other enterprise customer relationship management kind of services from other vendors. At the heart of it is, at the center of it is the Microsoft Azure. Those of you who don't know what Azure is Microsoft's cloud platform. It is basically a cloud where you can go and build all these various solutions to solve whatever the problem you want to solve. At the Azure basically has a lot of data centers. The way we work through is we have regions and geographies, and similarly we have India as a region and a geography, and similarly Australia, US. Within these we have what we call as data centers, And these data centers are where these Azure or cloud services are available to you. So any organization, or if any university, if you are looking to develop a solution, let's say you want to work on deploying a simple, let's say, a software pipeline on to do any particular task, you would basically sit on your desk, you would log into Azure through a portal, and portal will provide you a list of services, and through those list of services you would go, you would deploy a virtual machine, a storage, or whatever you want to do. So that's what the heart of is Microsoft Azure. And it is one of the biggest service which powers some other clouds as well. Office 365 also provides a cloud service. Dynamics also provides the cloud services, but it's all powered by Azure behind the scenes. So just on a very high level, 20,000 feet view of what Azure is, if you look at it, the infrastructure below layer is the compute network storage part of it, which is mainly your data centers, where you have racks of compute and storage are lined up together, and they're providing those services to you. But you don't have direct access to those compute and network services. On top of it, we also think about serverless. It's mainly focusing on the application layer. For example, you would look into the web, you would look into the databases, mixed reality, containers, or Kubernetes platform probably is the most widely Kubernetes platform used worldwide. So that's another one which you would look into deploying this on Azure. And on the top is the edge devices. The edge devices, the whole idea is we think about cloud is as a centralized place, but then we also think about edge as the device or which is closer to the user. For example, if you are sitting at your computer could act as an edge device rather than a cloud device. The idea is to use a low latency services close to the location of the consumer rather than sending traffic all the way to the cloud. And edge is very much popular and popularized with Internet of Things. And for example, we do work with a lot of organizations who let's have these IoT sensors in an agricultural field where they're capturing what the humidity is, what the temperature is. And these IoT sensors basically send the data all the way to cloud to do the processing and the analytics part of it. On the right-hand side, I've listed some of the tools. These are again Visual Studio, GitHub. These are the software development tools which you would use to build your solutions. And on the top where we have Azure Stack Edge and Azure Sphere, these are the appliances. Think of it as a hardware box which will sit on a customer premises or close to where the user is. And that's where you would run your machine learning and AI services on top of it. So that's on a high level. It's Azure. If you haven't explored Azure, I would strongly recommend go to your whatever browser of your choice, search for Azure, Microsoft Azure. You get $200 of free credit or 10,000 rupees. Log in and play around with it and see how you feel about it. Now, coming back to the AI part of it. So when we speak to a lot of executives around the businesses and commercials around the world, we see 90% of the people or 90% of the CEOs and CIOs have AI and ML as part of their core strategy, which they want to deliver in the next financial year. And one of the reasons for them to deliver is they do want to reduce the operational cost, and cost drives a lot of business decisions. So operational cost and efficiency, they want to improve on efficiency of their organizations. That's where they are investing in a lot of skills around AI and ML. And we are already seeing there's already 270% growth in enterprise AI-based tools. I would say 60 or 70% of the organizations now use AI in some shape or form to improve their business processes within their organization. But the challenge has always been it's always easy to think about AI or think about ML or what problem it's going to solve, but it's very hard to implement. There's a lot of AI models available. Currently, I don't believe there is any single marketplace where you can go and buy and purchase an AI model and say, okay, I need an AI model to do video analytics and go and deploy it. That's not available at the moment. There's a lot of machine learning skills, like it touched upon, requires to build these custom specific models. For example, you can have a speech recognition AI model which wants to listen to specific language dialects, which means a lot of customization is required. And also you need to connect these models to your UIs or your data sources from where the data is coming, and how these models can be hosted within your apps on your mobile. So in Microsoft, when we think about Azure AI, we always think about in terms of democratization, which means we want to empower every developer, every data scientist, and every citizen to use AI and build solutions on top of it. So the three areas where of three areas or three value propositions which we provide is mainly around developing AI solutions on your terms, which means we are the only cloud provider which helps building these solutions. There's a huge array of built-in, ready-made AI models or AI solutions that you can just build into your app or in your web app and just go from there. The second, you can also build into your mission-critical applications around it. And the third one is adding the responsible AI part into it. When I say responsible AI part, we don't want to build AI models which are skewed. We don't want all the answers coming to us which is skewed to a particular geography or demography within your AI or machine learning construct. And it also comes back to the data privacy reasons and also the security standards, which are mandated by a lot of regulated industries in the market. So all this is underpinned by what we have is Microsoft research. So we have a lot of research papers which are published. There's a lot of doctorate, PhD students who help within Microsoft research labs, and they build on these machine learning models. We have 8 global research centers, and you can see the one is in India. It's in Hyderabad. It's called IDC, and they basically also work on a lot of AI related their AI related work as part of their PhD thesis within Microsoft. So there's a lot of research goes into this for building those machine learning models so that you as a citizen developer don't have to build this on from scratch. So now coming back to what the portfolio looks like for AI technologies within Microsoft. So, and this is something I've tried to capture a lot of things from bottom up, or in terms of available services or products. At the bottom of it is that we call it ML platforms. And by the way, this is all built on Azure natively. So ML platform is what we call as Azure Machine Learning. So Azure Machine Learning provides a machine learning studio. Basically, when you're getting started with the machine learning, you need a workspace to do your compute. You need to build your Jupyter notebooks where you would do machine learning or write your Python code or whatever TensorFlow code, whatever tool you use to build your model. So Azure Machine Learning provides you a space. They have already pre-built starter templates which you can use and start writing your machine learning models. And these machine learning models could be very specific to some business problems. You can hook this to large data lake storage or wherever your data is, to your databases, and start working on it. On top of it is what we call as cognitive services. So cognitive services are also built on machine learning, but the machine learning models have already been built by Microsoft and provided to you as vision, speech, language, and decision services. So I'll go into more details into the vision, speech, language, and decision as we progress through the session. So these are pre-built AI models, which you just pick it up. And if you're familiar with the DevOps, if you're familiar with the CI/CD pipelines and those constructs, basically you build the model, have your code in GitHub, and get it deployed to anywhere in the world, whether it's to your home laptop, whether it's to the edge computer device you want to deploy it on, or it could be a camera which is sitting in your home, or it could be a camera sitting in a retail store, which is counting number of people entering the shop or number of people leaving the shop. So these are the AI models which you can basically start using it from day one. Using these AI models, we what we have is we call as applied AI services. Now, applied AI services or scenario-based services, these are built on customizable AI models. So some of the key ones we have a bot service, we have a bot service to build your bots if you want to build bots, and if no one has actually played with the bots, I do have a small video I touch upon how to get what the value bot service can help you with. We have cognitive search, we have content moderator, form recognizer, video indexer, metrics advisor, and immersive readers. And you'll get to I'll touch this in a little bit more detail as I progress. On the top of it is a Power Platform. The whole idea of Power Platform is that you don't have to use or know coding. So the way our organization is focusing is your focus to be on no code skills, which means anyone sitting next to you can build these apps without any coding knowledge. So it's basically drag and drop to whatever you want to do. So Power BI, Power Apps, Power Automate, and Power Virtual Agents are used a lot and extensively within enterprises, so that any business user can actually build these apps. It could be approving leaves, for example, or it could be um, releasing your salary statements. It could be related to tax, or it could be getting approvals for any new equipment you want to order. So all these tasks can easily be automated without any manual or any person actually sitting to approve it. And again, on top of it is the applications, and where you will build applications using UI. So whenever you'll build the application, you'll have these Azure AI services embedded within it. So that's the whole technology stack from bottom to up, and it's basically just the AI. If you touch on Azure, this is extensive. So more than 300 services which you can consume and build. So possibilities are really endless. Now, so I've touched a little bit on the Azure AI part of it in the previous slide. So what we're going to do is now is we'll move through top to bottom. I'll focus on some of the Azure applied AI services, so you get to experience what the value these services provide, and then I'll touch a little bit on the cognitive services behind it. I'm not touching on any of the Azure machine learning or deep dive in today's session. Right. So when we think about Azure applied AI services, we think about mainly in the context of business logic, as in what business problem we are going to solve. If the business is not coming back with a problem, we don't usually look into more details. So the way we look into it, we have two parts of it. The first part is obviously the business logic, which is what the business want to do once it has the output of the model. And the second is what AI model we need to be using. So can we use Azure Cognitive Services? Can we use any AI models, or do we need to use anything customized with Azure Machine Learning? And mind you, with the Azure Machine Learning, you need to have very specific data scientist skills. When I talk about data scientist skills, it means you need to know how the regression works, how the linear regression works, and how all these different algorithms work. So you need to understand a little bit of statistics before you can build any machine learning on it. But luckily, Python and other languages does provide some of the libraries which you can embed and start building through it. I hope this is giving you a bit of sense of where, in terms of hands-on, we are using AI models and how we are moving into next 5 or 10 years, where the industry is moving into. If you have any questions, by the way, feel free to pause me, and I'll be able to answer any of those questions. Okay. Okay, so Azure Applied AI Services. So these are the six services which I'll probably discuss in next 20 minutes or so. So when we think about applied AI services, it's mainly related to what we can use or how we can use Azure AI to get the insights from your organization or get the maximum value out um, of our conversations with the customer or generate value and offer it back to the customers. So we have the basic ones, which we call as applied AI services. The first one is the Azure Video Analyzer. It's used to analyze your videos. So if you have cameras at home, or if you see any cameras in a mall or a shopping center, you can actually deploy this as a container service within that camera to analyze whatever you want to analyze, basically. So I have some experience, first-hand experience working with one of the largest telecommunication providers in Australia. They have deployed these video cameras, and they basically, at the very basic level, they just count the number of people coming into the store and count the number of people going out of the store. They also try to come up with a heat map of where the more people, a lot of people are standing. For example, there could be that there's a bunch of people whenever enter in a retail store, let's say a Geo store, for example, more people are standing more next to iPhone than to an Android, for example. So it can also help in those scenarios around it. Another classic example is basically using for a number plate recognition. So if you look at traffic light cameras, these cameras can also recognize the number plates, and those number plates can basically be mapped directly back with your traffic authority. Similarly, we have monitoring. We have Azure Metrics Advisor. So Azure Metrics Advisor is basically it captures all of the metrics coming through your appliance. And one of the example I'll discuss in one of my slide deck is around predictive maintenance of Samsung TVs, for example. And if it gets deployed there, the way you're trying to use your TV, it will try to capture all those metrics and to try to predict when your TV is going to fail. Ideally, no one wants the TV to fail, but this is some of the usage and usability of AI services. Conversations, we have Azure Bot Service. You probably have seen a lot of these bots in your interaction with communication providers or anywhere, even with the health authority. These are the bots which keep popping up on your web or in your mobile and saying, hello, Anshul, how are you doing? And this is something which you can use. This service is something which you can use to build the bots and deploy these bots if you are developing an app for yourself. So providing question and answer, providing help, or even providing some documents around it. The third one is the form recognizer. So form recognizer is basically, it's built on top of OCR, which is optical character recognition concept. So basically it captures everything in the form in a manual form. It captures that information in form and then extracts and pass that information into a database. So once it's in the database, then you can run your own analytics or business intelligence on top of it through it. The next one is the cognitive search. Cognitive search is similar to a Bing search or a Google search, but it's for your organization. For example, in Central University, if you are reading something or you have, let's say, a huge number of documents or papers being published, you can have these cognitive search and search through it who has published what, and it provides some contextual information around it as well. Last one is the Azure Immersive Reader. So that is mainly from accessibility point of view. It's mainly for people with autism or people who are dyslexic. You can use Immersive Reader to highlight certain words around it and to make it more usable for the people who have those abilities, in comprehension abilities. So now let's look at Azure Video Analyzer. So I touched briefly on Azure Video Analyzer. I don't think I've added any video to it. But the whole idea is that you would capture video insights from it. So the way it works is it's basically a module. Azure Video Analyzer is a module on Azure. So that video module can be deployed anywhere. So we have tested, like I touched on a few examples, how we have tested with one of the telecommunication organization here in Australia, and we are testing with Geo and few others in India as well. So this is basically out of the box. You're available to you. Now, if you need any customization around it, then you can add your own AI module tailored to it. Some of the use cases which we have seen specifically in US is around workplace safety. So whenever, let's say we have a construction site, and when people want to come into the construction site or to in an office, they need to be wearing a mask basically, and they need to have a hat, and Video Analyzer can help you detect and notify when someone is wearing and when someone is not wearing. So that's one of the example or use case which where Azure Video Analyzer is used. Another a classic example is digital asset management. So it's basically the cameras of sitting in front of an inventory. For example, if you're ordering anything from Amazon or eBay or any of your favorite retailers, these packages, when they move through the conveyor belt, there's the cameras we are sitting on top of it. So these cameras are constantly seeing if the package has been opened, or if the package is at the right limitations or dimensions for to be added into the to the airplane or not. And it can also detect other things as well. For example, classic example is mobile phones. For example, if you order a mobile phone to in mobile phone manufacturing plant, there could be a possibility where the screens, when they go through a QA testing, the screens are basically broken. So Video Analyzer, again, with a video analytics model on top of it, it will start looking into what are the various video phones which have a broken screen or not. So these are the things which you can think about when to use Azure Video Analyzer through it. Super easy to start with. As long as you know a little bit how to code, it's super easy to use it. I've touched briefly on the Azure Video Analyzer already, and it basically fits very nicely with the video management tools as well. So basically, let's say you have a petrol pump, for example. The petrol pump where you have a video camera sitting on top of it, and it's analyzing how many the cars are coming and the cars are going. If you see the car is coming, they have filled up the petrol and they try to drive away without paying any money, and it can trigger an action to it. We call it end-to-end actuation. So it will trigger an actuation, which means it will suddenly send a message or alert and capture a video footage from where they got in to from where they got out into the petrol pump. And then you can analyze it or go to police or whatever you want to do. It's up to you. But this is the actuation part of Video Analyzer. And for that, you need to have a video management solution in place as well. Again, built on AI models. And these AI models have already been trained by Microsoft Research so that you can start using the service from day one. So that was the video part of it. Then now we'll touch on monitoring. So monitoring is mainly around detecting anomalies. This is probably one of the biggest use case in AI, detecting anomalies when something is out of pattern, basically. And that's where a lot of organizations implement Metrics Advisor. So Metric Advisor, they continue to monitor with the time series to see what equipment is going to fail. So they try to predict what is going to fail. And when it's going to fail, they try to replace the equipment. And it's used in a lot of manufacturing plants or even in mining plants to see that all their machines operate and stay up to date. Classic use cases include business metrics monitoring, AI ops, like I said, DevOps. If you're across it, then AI ops is similar model. AI ops is a methodology around how to build AI model and how to deploy an AI model from your laptop, from where you're coding, all the way to the consumer or an appliance who's going to consume the AI model. So that's a whole AI ops based scenario. I do have this video here. I'm hoping you can hear the voice. Let me see if I can play it.
Unexpected problems happen. A store underperforms. A new conveyor belt part creates unusual rhythms. There's a sudden spike in online traffic. And reacting quickly is critical. What if an AI-powered service could help you stay ahead of issues, proactively monitor the performance of your organization's operations, and notify you when problems arise? Metrics Advisor streamlines monitoring, diagnosis, and notifications. Embedding advanced analytics into apps can be complicated. Metrics Advisor is a straightforward approach. Its user interface gives you everything you need to manage monitoring and diagnostics end-to-end. Say there's unusual behavior in your data. Metrics Advisor pinpoints it with the help of machine learning. It accelerates troubleshooting with powerful root cause analysis, filtering out false alarms and signaling the key drivers so you can fix the issue before it becomes a real problem. Additionally, Metrics Advisor's simplified data preparation makes ingestion a breeze. It's a powerful combination of granular analysis, real-time monitoring, and adaptive models without the need for machine learning expertise. Metrics Advisor is the expert that will help protect your organization's growth.
And based on it, it's basically the metrics advisor. Again, we have broken down into the business logic and the AI models. Within the AI model, you can see we have anomaly detection models, and we have also a root cause analysis model. These are again machine learning models developed by us. What you need to do is to use Azure Metrics Advisor in your business logic, which means you need to connect it to your data, you need to add into your app, or you can build a completely new UI user interface for monitoring how it's doing it. So this is the example I was talking about, the Samsung, for example. If you have Samsung TV, what Samsung uses is Azure Metrics Advisor to make the TV much more smarter to detect and diagnose anomalies. But there's a lot of AI is built into the Samsung. It's not just Samsung is using from Microsoft. This is the only model they use. They have their own proprietary software, or sorry, proprietary models or AI toolkit developed, but this is used in conjunction with it. It has helped helping customers to get better service when they basically purchase a Samsung TV. So these are some of the examples how these models can be utilized by the organizations to basically improve the experience. Next one is the Azure Bot Service. I've already touched on Azure Bot Service a bit, how you can build bot. As you can see on the on this diagram here, it's basically drag and drop how you want to use the bot service, and its key use cases include your customer service, smart personalized care, or voice control as well. And you've seen, if everyone uses Facebook, as you have seen that in Facebook, you have a messenger app similar to messenger app. What people do is, if you go to I'm not sure if Amazon India does that, but there are a couple of apps in Australia where, as long as you reach the app, there's a chat box sitting next, and it says, "Hi, how can I help?" That's basically not the real person sitting behind the scene. It's the bot service they have developed, and they try to preempt what the questions you're going to ask. For example, you may say, "Okay, what's the update on my case?" For example, I raised a case that my phone is not working, or my washing machine is not working. What's the update on it? So what they try to use is they try to take clues and from the natural language, and they say, okay, what could be the next expected question for the customer? So they would present basically as saying, okay, give me your case ID, for example, to look into it, and they'll provide all that information. So what the organizations are doing is they're basically reducing the calls which you make to their call centers by just building their bot service. It significantly improves their operational footprint and how they do their business processes. Similar to bot service, we built what we call as healthcare bot. And healthcare part was very instrumental, especially in Australia during the COVID. So during COVID, that bot was released by government, Australian government. And if you would have any symptoms, the bot would try to analyze and filter out what needs to be done, what doesn't need to be done, what area you are living in, and what are the closest doctors you can get your basically a video call consultations from it. And you can have all the billing and payments attached to it to solve that, to help you go through it. So that's where it is used. It's also used for mental health in a lot of the cases, basically mainly for getting mental health services. For example, if you're feeling a little blue and you're not feeling great, it's basically bot tries to engage you in the conversation, and try to connect you with the people where you can actually talk and talk about what it is, and probably connect you to the clinical psychologist or whoever you want to connect to. So these are the services which can automatically be built within the bot service to do it. Yeah, I do have another short snip.
When customers or employees have questions, they want answers fast, 24 hours a day on whatever channel they choose. Conversational AI can help. That's why we've enhanced Azure Bot Service, empowering you to quickly build bots that extend your brand, all within an open source, comprehensive development experience. First, start from scratch or with conversational templates and reusable dialogue components to create multi-channel, multimodal chatbots that are both text and voice-based. Next, infuse these bots with high-quality AI from Azure Cognitive Services to respond with natural language or a customizable voice unique to your brand. Then, test and debug your bot in the same app you used to build it. Finally, publish your bot to Azure and connect to the channels where users are, like contact centers via IVR, digital channels, or Microsoft Teams with minimal code change. Azure Bot Service gives users a great chat experience to securely build, test, and publish your bot all in one place. Start building today.
I've already touched on Azure Bot Service, how you can do create this service. Behind Azure Bot Service is what we have is we call it LUIS, LUIS. That's a natural language understanding engine. And this is one of the language model or a speech model, which has open source language and speech models, which can be used to empower it so that your bot can understand your language, not just understand the language, it needs to understand the context around it as well. So this is the bot service. The next one is the form recognizer. So form recognizer, as you can see, it's the whole idea of form recognizer is to extract the text and structure it and add it to a database. So if you have a form, let's say a PDF form, which is being regularly generated, how do you convert directly into database entry so that you can do something with the data rather than you don't need a data typist to take the data and feed it into the database, or database engineer to do any of your work. It's basically you run the form through the form recognizer, you highlight what is the pieces of information available, and then it goes directly into the database. So again, it's deployed anywhere. You can deploy it on the edge. When I say edge, you can actually have a mobile phone, and if you want to scan, for example, one of the form from a customer, you basically scan the form. It automatically captures all your address details. It captures your account details or case details, and feeds that into a database. And the common use cases are listed here: claims management automation. So insurance claims is the key one where it's used. Document process automation is the very big use case, which is used by a lot of law agencies and also the universities, where they have piles and piles of documents. They basically run through the Azure Form Recognizer and then feed directly into, basically digitize the data from a physical copy.
Form Recognizer starts by learning on a few sample forms and applies machine learning to understand and identify the structure of those documents. Then, it extracts the information, keeping the context and relationships between fields intact, and outputs the information in an organized manner.
Yep. As shown in the video, it's really straightforward, the intent of Form Recognizer, but you need to have an experience around how to build it and highlight what data needs to be extracted. Again, this is the same what AI model it has been built on. It uses optical character recognition, and it also uses pre-built and custom documents. And it also provides you the samples which you can use it. You can basically write content with your hand on a paper and then test it out with the Form Recognizer, what data is it's extracted and where you want to store that data. It could be as simple as a JSON format. And if you're not familiar with the JSON format, that's a JavaScript object notation, and it's used pretty much 100% of the websites around the world when they try to transfer the data through your APIs. So JSON as a payload on your calls is used for sending this information out. That's one of the examples. Chevron, as you may know or may not know, is one of the largest oil and gas organization in the United States. They basically, all these engineers create reports which can go up to 75 to 300 pages of these reports. And these are generated through a lot of oil wells around the world. And everyone has a different style of generating the report. For example, report which Chevron in US would generate would be different to Chevron UAE, for example, would generate. And they have different formats of generating. So this is a classic example of where they have used Azure Form Recognizer to solve this problem. They basically standardized it by sending or using all the data from the forms and feeding that into your end systems. And once this data is in the end system, then you can use your knowledge mining to get insights out of it. Okay, I think we've covered 4 of these. 5th one is the Azure Cognitive Service. Or search, sorry. So I've already talked about how you can provide the content search around it. So Azure Cognitive Search is your own local search, and then you can add your contents or context around it when you're trying to search, let's say some papers from certain years which may have certain context around AI, for example, is one of the use case. Some organizations, especially the retail, for example, Walgreens, they use searchable content through cognitive search. So basically, they have built and deployed this service, which, by the way, was already powered through some of the services or technologies which we use in other services. For example, SharePoint and OneDrive. That's also used. That search engine is the same powerful search engine used for your enterprise intranet-based search. And here's an example.
Information is often unstructured, scattered across formats, and siloed, making it hard to find answers. With Azure Cognitive Search, you can create best-in-class search experiences harnessing the power of machine learning. Built-in vision and language cognitive skills enable users to make sense of all types of content. You can even integrate your own custom ML models. Traditionally, search results were based on syntax, like how often a term appears in a document. Now, with the all-new semantic search capability, you can get the most relevant results based on intent, not just keywords. Semantic search surfaces the most relevant results and even finds specific answers out of hundreds of thousands of passages, helping deliver the most pertinent results. Cognitive search is fully managed, secure, and scalable, so getting started is easy. Bring structure to your information and find exactly what you need fast.
Yep. So I hope these short videos are giving you a sense in terms of how these AI services can be used. And again, broken down into business logic and AI models. So the AI models are extensible using machine learning. You can have particular model built for your use case and can be embedded into Azure Cognitive Search. Wix is again is one of the website providers where you can just go and build your websites. They also use Azure Cognitive Search in the background, and yeah, it's again one of the key partners with us who are using our services to solve and improve experience for their customers. And the last one in Azure Applied Services is accessibility. So as you can see, this is mainly you can have certain things highlighted, and it's the idea is to improve the reading comprehension for the people who have dyslexic or autism or some reading disability. And it's the idea is to provide learning should be accessible to everyone. And to empower those users or those individuals is where we have Azure Immersive Reader. And it'll become more clear from this video snippet how this can be used to improve lives of the people.
I'm Jenny Anderson Johnson.
I'm Ben Johnson.
We have 3 kids, Alden, Gavin, and Carrick.
My name is Carrick and I'm in 2nd grade. My favorite things in the world is bees, snakes, and gardening.
We definitely knew there was a problem because, he just was not being able to read with us as much as the other kids were.
Sometimes I was embarrassed because I don't know how to read.
He had dyslexia. Initially, it was that kind of feeling of shame that really made me feel sad.
My teacher was like, who wants to read first for the whole entire year? I said, not me.
So you start wondering, what were you doing wrong? And then there's a little bit of panic that sets in.
One day when we were learning, my friend came next to me and said, I know how you can do this. Just click on that button, and it said Immersive Reader, and I clicked on it. And I was just focused, my eyes were focused into it. I can say it to you, like that. And I could tell you a picture.
The awesome thing about Immersive Reader, it was just there. It was just an icon click away.
I think that it's allowed him to have more confidence that he can do more.
It makes me feel good, and my life is more easier.
The first night he kind of came up to us with a book in hand and wanting to read to us. You see that twinkle in his eye.
Yeah.
It was something he had conquered,
This card was from Mother's Day. I love you, Mom. I am very impressed of your hard work that you did.
The last few sentences was, thank you so much for helping me read. I was like, wow, this is the best Mother's Day gift. Yeah, it was pretty, I don't know. Yeah, that one little sentence, it was kind of.
I am going to read as many books as I can in the world.
That was touching, wasn't it? Anyway, so moving forward, again, you can focus on parts of the speech. You can have language auto detection. You can create how you want to present this to your users. And again, there's a lot of text to speech to text, text to translators, basically. I was going to say another one. Anyway, and custom document models, which can be underpinned through Azure Immersive Readers. So I think that's it. So that's it. So what we've covered so far is the Azure Applied AI Services. So I hope it gives you a sense where AI can be used. It's not just in the books, but these are the practical implementations of how it's being used around the world, and how it's solving a lot of problems and a lot of use cases around the world. The next we're going to, let me see what this is. Yeah, I think we've covered most of it anyway. And this is where is basically the portal. So what you have in front of you is the Azure portal. Once you go into the portal, you can see a marketplace. In marketplace, you can see these are basically like buying shoes online. So you have form recognizer, you have cognitive search, bot service, video analyzer, metric advisor, immersive reader. So all you have to do is basically create, and it walks you through certain steps. Once you have those steps sorted out, you can build this as a container, or you can just leave it as it is and embed the APIs on your app. For example, like I said, if you are building an app, Android or an iOS app, you can have your app capturing form recognizer data and sending back to the form recognizing processing engine before it gets stored into the database in the backend. And similar for rest of the services. We have some great partners who are extensively using these services, and not just for their customers, but also to simplify their own processes within the organization. And like I said, there's no machine learning expertise required. You don't need to be a data scientist. The whole idea is to be a citizen developer. So when I say citizen developer, everyone in your neighborhood should be able to develop these apps. Just plug and play into their apps or whatever their use case is. And if you are a little bit more from software engineering background, there are APIs available. There's software development kit available. You can use Java, C#, Python, and JavaScript as well. Well, most people use Python anyway. Right, so next part I'm going to touch is on the Azure cognitive services. So the 4 cognitive services I'll touch on is the language, vision, decision, and speech. All right, so the first one is the vision. So vision is, again, cognitive services. Azure Video Analyzer is built on top of Vision Cognitive Service. So you don't have to use Azure Video Analyzer, which is a prepaid product in your app. You can also use the Vision Cognitive Services to fine tune it what you really need to do. For example, if there's any custom vision model you need to build, let's say if you want to build a custom model to identify, let's say, the birds sitting, coming to your house or sitting in your neighborhood, and you want to identify what those birds are and what's the frequency they're coming in. So you can build all these models, custom models for it. So it does image understanding. You can extract the text. For example, a classic example is the number plate. You can extract the text from the number plate, like a photo. You can caption an image. You can do form recognition. We've already touched on form recognition. Facial recognition is another one. But the problem with the facial recognition is, although it sounds very cool that you'll be from facial recognition, once you get into, let's say, a bank, they analyze your face, and that is basically your face is your password. But the problem so far is it's being used by a lot of agencies or security agencies worldwide, and our organization has taken a stance that unless and until we work with the privacy laws, or we have responsible AI or some regulation around it, we won't be able to provide facial recognition services. So in this context, what you can basically do is, if you have an image, let's say if you want to recognize, it won't recognize who you are, but it will recognize, for example, a gender, whether you're male or a female, for example. And it'll try to guess, let's say, the age, whether you are 20 to 30, 30 to 40, 50 to 60. So that's the minimal form of recognition we use to get some data out of it. Spatial analysis is another one. You may have seen spatial analysis in our competitors' products, where you basically point to your phone, you can see what is the distance from your sofa to your bed, or what's the difference between 2 walls, for example. So all that can also be built within Vision. It also comes back to what the application you want to build. Speech is another one, speech recognition, and probably this is the most familiar you are with the speech one. It's Amazon has products, and similarly Microsoft has these products on the speech, and Alexa and Google and Echo, and all these are classic examples of speech, where you can say, Alexa, play, I don't know, some bhajan, and it'll start playing it. So that's a speech one, but you can also use this speech in your headset, for example. Let's say if I'm wearing a headset and I end up in Japan, I don't understand the language. What you can do is you can real-time basis, you can translate the language from Japanese to English or to Hindi, as long as you have built that language understanding model into your app or into the software you're building. So this is another one used. Language is another one, and language and speed goes in together. Again, your intent understanding is at the top one, and we'll go through some of the examples. And the last one is decision. Decision is mainly around predictive modeling, predictive maintenance, anomaly detection, root cause analysis, really what decisions you want to make if something is not right. So the AI model tries to predict what could be done. So as you train the model through all these decisions, the model gets better, better, and better. So first time, model may come back with the wrong result. You train the model again, it result may improve by 1%. You train the model again, it improves by 20%. So you continue to improve the models until the model become at least 60 to 70% accurate in predicting what it's going to be. Classic example is you can have an apple and you can have basically an orange on a table. How would your model, let's say a vision model, would detect whether it's an apple or whether it's an orange? So you need to train your model with an apple images and you need to train your model with an orange images. And when I say image, it's not just one image. You need at least 10 lakh images to train the model, which means your model, when it gets trained on so many images, you need to have that much compute power. Your normal laptops cannot handle it. You need a huge CPU grunt, you need GPUs to do that processing around it. And that's where the power of cloud comes into the picture. You can't train all these models at that scale on your Dell laptop or a Lenovo laptop. It has to be done on a large computing power provided by the cloud providers all around the world. So here, it basically, what I'm touching is what are the areas where you can actually make amends, as in customize it. Custom vision, we have computer vision and custom vision. Custom vision, like I said, could be anything, which means the models can be customized or the service can be customized. Form recognizer, speech is another one. The third one where I have language, at the bottom of it is a Q&A maker. It's basically a question and answer maker. So what we're trying to do in one of the organizations, that's again one of the use cases, they have a lot of documents in terms of when they do their deployments, any sort of server deployment, they create what we call a solution architecture document or a design document. So they have piles and piles of these documents who have been building from 1990s until 2021. So what we're trying to do is we're combining all these documents using basically our form recognizer and also the Q&A maker. So once these all documents are in the database, so Q&A maker tries to understand and relate the document. So you don't have to read through all these documents. You basically go to a Q&A maker and say, okay, can I find out what was just making an example up, what was the specs of a server which was deployed in 1992? So you don't need to look into the document. The Q&A maker will do the answer. It will do the search and will give you the answer straight away. So that's the power you can use with these cognitive services. Moving on. So this is the classic example of vision, where you can see that what it tries to do is it adds a bounding box around who is doing what. So it has identified in this example, for example, it's a person and it's on the skateboard, and it tries to add a tag around it. And you can see that tagging can be skating, snowboarding, sports equipment, outdoor, and it has some metadata associated with it. For example, your image format, your image dimensions around it, and this is what you can do for it. And vision is being used, like the example I gave you earlier on the mask. For example, if you get into one of the, it's becoming mandatory for a lot of organizations that employees wear masks when they enter their university or when enter their office. And this can be employed where if the mask is not being worn, then it basically sends an email directly to your manager that you need to be wear a mask. So that's what it is. Speech recognition, speech. This is again what it's talking about is that speech recognition models have become so sophisticated over the last few years that it is reaching human parity. So I think I may have an example around, yeah, for example, this one. So let's say someone says, oh, that's about how old ours is. So, hang on, I think it missed. Yeah, this one. So if you look at this, there are different people have different styles of saying things. For example, the A1 says all about ourselves. The B says that's about the horses. So you can see that all hours and horses, all hours and horses is very same or very similar sounding. But the models have become so sophisticated that it will be able to differentiate or add the context around it, what you're talking about. Are you really talking about the horses, or it's about all hours or how old ours is? So these are some of the language models which are used or have been developed by researchers all around the world. And like I said, it has improved a lot. And the natural language processing is probably one of the most researched AI field, especially around the universities, in the universities. So Microsoft did purchase one of the open source model for natural language processing, which was called GPT-3. So GPT language model is so strong that if what the scientists or what the researchers tested it, you can feed some information to a GPT model. You can say, okay, sports, for example, you just provide 3 keywords. You provide sports, you say today, and you say cheating, for example. The model is so good that model can use those words and write a paragraph out of it for you. And you won't be able to tell whether this paragraph has been written by a machine or a model or an actual human being. That's how the model has has become so popular. And if you're curious to know, just go online, search for GPT-3, and that's probably one of the top language model used worldwide. Yeah, that's again, general language is reaching human parity around it. And it's trying to analyze who is they in this particular sentence, and coming up whether it's a city council or a demonstrator. So, and then we have decision as the last cognitive service, and then the decision, it basically talks about, like I said, anomaly detection, and this is all around reinforcement learning and how you are training your models or detecting anomalies. So one thing to be mindful is it's not that it's one or the other. Often when these softwares are built by companies who are building these process automation softwares around the world, they use mix and match of these services. These services are most like a Lego blocks. So you basically use a vision, you use language, then you can use bot service. You use mix of these services to build a complete value proposition when you're going to offer any product to your customer. I'll skip this. I've touched on this already. So again, I've touched vision for analyzing images and video. Speech is for spoken audio. Language is natural language processing and sentiment analysis. I should have touched on this. So another example of language model is sentiment analysis. So you know how social media is full of hatred. If you go to Twitter, you go to Facebook, it's mainly people think they have a right to criticize everyone. So let's say you're not happy with your bank. Let's say SBI Bank comes up with a policy and you're not happy with it. So people start feeling that you are not great. You need to improve. Your customer service is rubbish and all this. So what these organizations can and usually do, especially some banks in Australia, what they do is they run what we call a sentiment analysis. So they try to analyze all these tweets and try to understand what is the sentiment behind it. That's all built on your language model. So they would say, okay, the sentiment is positive, sentiment is negative, sentiment is neutral. So in order to improve their customer experience, they measure themselves on sentiment. So the idea is move sentiment from a negative to a positive. So you would see people coming forward to help you out, even if your experience hasn't been great. So that next time when you something gets resolved, you post on Twitter and say this was great, and then people would actually yes, and also the organizations would see that the sentiment is improving. That's how they try to capture value from the customer. All right, so that's basically I've covered the two parts of it. I've covered the applied AI. I've covered the cognitive services. Initially, I covered Azure. By now, whoever is listening carefully and not falling asleep or not eating lunch, or whoever is paying attention to this session may have got a good understanding where we are and how we have reached here. So the last part of it, it's the second last part. Basically, I'm going to touch on the healthcare, how some of where the focus is for our organization, for Microsoft, in healthcare. The way we structure ourselves in Microsoft is we do very industry-based work. So we have a team which is focused on telecommunication, teams focused on healthcare, teams focused on retail, focused on financial services industry, focused on manufacturing and mining. So industry is a very huge priority for our organization. And we saw a lot. So the team which is on healthcare is basically they work with a lot of hospitals around the world, and they played a very fundamental or pivotal role in the COVID in last 1.5 years now. So they worked with the authorities to report on number of cases, how those cases are reported. It's not just about reporting the cases; it's all about what your 7-day average is, how many people were isolating in that time, how many people were doing quarantine, how many people get infected, how many people died. All this analysis powered by Microsoft tools and technologies behind the scenes. But when it comes to applying AI in healthcare, a lot of healthcare executives, when I say healthcare executives, these are the people who are running big hospitals around the world, where they provide services to the patient, but they also want their hospital to be sustainable, that is making enough money to continue to provide those services to patients. So this is some of the data which I've captured from Gartner and Forrester research. 84% of the healthcare executives believe that AI will revolutionize how they capture information from the customers, or when I say customers in healthcare terms, it's mainly patients. They also think pharmaceutical industry is going to be $1.8 trillion industry by 2024, and some other metrics they try to measure. And this is the critical one. 81% of the patients are not satisfied with their current healthcare experience, whether it's at the hospital, whether with the doctor, whether your labs, whether you're going to give some test. 81% of the people are not happy. So this data says that there is a lot of opportunity which can be applied within healthcare, or how AI can be used for it. So basically, when we think about where the innovations are going to help in healthcare, the three main pillars where my company is focusing on is enhanced patient engagement. It's always critical how you capture patients' information and how patient is through the journey from during the let's say from the day patient is admitted or diagnosed to the services patient is getting, and when the patient recovers, for example. Second one is improving clinical and operational outcomes, is obviously around the diagnosis and improving the results of the diagnosis and feeding that back to patients. And the third one is accelerating scientific innovation, which is mainly around building new drugs, for example, Covaxin or AstraZeneca or Covishield. That's another area where we think AI can really help building these drugs. Right, so here I have some examples around how we are partnering with some of the biggest centers in the world. So enhanced patient engagement is CDC, and I'll touch on some NHS, Volpara, Adaptive in next 5 or 10 minutes before closing out. Right, so let's focus on enhanced patient engagement. So enhanced patient engagement, the centerpiece is basically the smart personalized care. That's how we say that the patient providing help to the patient. So in smart personalized care, there are a couple of things which patient, especially in the Western countries, you need to have certain documents if you need to see your doctor or a GP. For example, you need to have a certain insurance purchased, and you need to have medical records registered in your national register. This is again some of the data which we have at the moment that, for example, 97% of the patients expect that any healthcare institution to have full access to their medical history. For example, if you move from Dr. A to Dr. B, you don't have to explain everything or take all your tests again. Dr. B would have access to all your medical results so that you can start the diagnosis from day one. Then there are some other things. For example, 77% consumers book medical appointments online. That's another area where AI can help. 80% think consumers willing to wear smartwatches that measure the health data, and this is popularized by Android watches or Mi Watch or Apple Watch, where it's constantly capturing data. If you accept or you agree to this data being sent to the health data providers, there are certain health data brokers in the middle. They'll basically start capturing that data, and if you agree to it, it's based on your consent, and then it'll start feeding that back to your hospital or to your GP or your doctor. So basically, what this talks about is how AI can use or transform smart personalized care. So the idea is that you will be able to service these patients in real time, or one of the solutions developed out of it was screening the patients for COVID when you go to a doctor, for example, and this is being used in US and UK. So you will have a bot service running, and bot service will try to ask certain questions to see, okay, have you been in touch with any COVID patients? What are the tier 1 location sites where you have been? And those are the questions to filter out whether you need actual doctor or you just need to know what medicines you can take and basically isolate yourself for 14 days. The outcome is basically what the value you would get out of it. So you would have access to care, better care, lower cost to ensure a healthier population. So this was the solution which was developed. If you look at it from the left-hand side, you have a healthcare specialist and you have an online patient. So patient is basically using COVID-19 bot patient interaction for conversational, what needs to be done. And you can also build speech into it so that you can speak in your own language rather than typing all the way. You can just say this XYZ has been happening to you. And the next is the conversational agent fluid. And then you have on the right side your databases on structured and unstructured data. And then you also have an analytics dashboard here, which basically to provide you information around analytics, how many patients came, how many patients had similar symptoms, how many patients had similar tests, and you can build all these analytics out of it. So this was a very high level solution on top of it, but when you translate into an actual deployment within an Azure environment, you would get to see what these services are. So bot service, which we talked about, was used for the patient interaction. Bot logic, this is the business logic which wrote. These are the APIs which were sent, And HealthBot, this is again some of the medical content, symptom checker. These are some of the internal bots developed to answer the external bot for a customer. And on the left hand side is the data sources, the data factory. Data factory is another one of the top product from Microsoft, which helps you building database related solutions. It also covers migration of data from, let's say, system A to system B. It's heavily used for even transforming data. And think about all your ETL processes. If you're across it, extract, transform, and load processes. If anyone has worked in the databases, or at least in theoretical sense, that can all be solved through Data Factory. So next is Azure API for FHIR. So this is FHIR is the health broker record information in US, and that's basically another party which provides these APIs. And then you have structured and unstructured data feeding into it. And the blob storage, Azure blob storage is a cloud storage. So think of it mainly as a hard disk in the cloud, your own hard disk in the cloud, so that you can store some data with the right level of access and control. And then you have Power BI analytics dashboard. So all these things make up a personalized care COVID-19 bot service. So this goes back to my argument earlier as well, that you need to have a bunch of these services together to present, to build a solution or build a software part of it. So once this is all done, this is all happening at the back end. What app you have built is basically just has the bot services and bot logic and a UI into it, as simple as it. This is all the back end systems which is running in cloud for you. CDC is using it. CDC is Center for Disease Control. It's one of the top body in United States, and they're the ones who report on daily COVID numbers and how the vaccination is going on, how many people have been vaccinated, and they also provide some advice around what to do in COVID, basically. This is again some of the examples around it. What was the situation? How they use healthcare bot on Azure to solve some of their problems, and the impact of it is basically Microsoft Healthcare Bot Service now developed can be used anywhere. It can be used in India. It can be used in Australia. In a lot of the government organizations, it's ready-made to streamline the whole process around it. That's another case study I've included here. I'll share these links if you are keen to understand a little bit on it. So the next one is improving clinical and operational outcomes. So the two areas of focus here for Microsoft is the claims management and automation. It's a health insurance claims, which is happening, and automation. For example, when you go to a doctor and doctor charges you, let's say, 10 rupees, then you need to claim that 10 rupees as part of your health insurance. So the way it is done is again through an app. You click the photo of that you have paid for it. It links back to your whatever the Medicare card or health card is, and it automatically gets processed back into your bank account. So that's the claims management end-to-end solution, which can be built on it. And the second is predictive care guidance around it. So we'll go into more detail, not detail, but maybe we'll touch briefly on it. So the claims management and automation is another one of the business problem which needs to be solved by health insurance industry, a part of healthcare industry. So some of the areas here is, for example, 12 seconds. By using an RPA solution, RPA is called robotic process automation. So some organizations such as UiPath, if you've heard of them, they build this process automation around it. So basically they have robots which are opening up a browser, they're clicking a button, they capture all the workflow flow through there. And they use basically AI services behind the scenes to do it. So what it says is that you are able to reduce the check the claim status to within 12 seconds rather than a human to go and log in and check within 85 seconds. Similarly, there are some other process. For example, it says Hospital cost to hospital, $260 billion is the cost to hospital on claims denials annually due to complexity of the claims management process, because there's a lot of third parties involved in the claims process. And if you've been to any of one of the Western countries, it does involve, when you buy an health insurance, there are so many intricacies around it. It could be your health insurance covers your dental, but it may not cover your kidney surgery. It may cover your orthopedics, but it may not cover some of the um, heart surgery, for example. So it can get tricky in terms of what is covered in health insurance, or and to have the claims associated with those health insurance plan you are on, it makes it a little bit complicated. But all this process can be streamlined, and this much amount of money, $260 billion, can be saved. And that's what the opportunity Microsoft saw with healthcare, to embed AI in within their organizations. Again, one of the classic example is classifying and digitizing the unstructured documents. So like you have your receipts, or all these things, you can basically digitize using form recognizer. You can use speech or language services, and add that into your backend systems, and drive some actions and insights out of it. So this is again probably talks about how claim automation solution could work. On the left-hand side, you can see there's an unstructured prescriptions, and it's being annotated with a semantic markup, and then you do the investigation. So this is on a high-level solution overview, but if you break it down into Azure services, that's what the solution looks like. So you have on the left-hand side, you have document ingestion. Document ingestion is your receipts or scripts. And on the middle is where you do classification and encoding around it. Again, some of the services probably you are not aware of it is Azure Functions. So Azure Function is again kind of serverless workflow service. Basically, you can write a bit of code, but you don't need to specify that it needs to run in a VM. It basically goes and runs your code without thinking about any of your hardware requirements. So it basically feeds into the blob storage, then Azure Cognitive Search, which we touched on, and then you have prescription claims identifier. Search index is also part of the cognitive search, although we do have another service called Azure Search to build that. This is the Cosmos DB is the database. It's called NoSQL databases. It's not your traditional RDBMS. It's basically all unstructured database. You can have scripts, you can have videos, you can have JPEG files, or anything. All that data, NoSQL data, can be fed into it. And the prescription claims specialist. So this is, I understand this is probably not being implemented locally in the areas where you are, but a lot of that's where everyone is trying to move to. Whenever we in India, if we make into start doing the prescription-based medicine, these models basically come alive, as in other European countries, or in Australia, or in US. Classic example is the NHS. It's again one of the insurance authority in US, and they basically use it to improve their 90% efficiency improvement through using Azure Cognitive Services. I'm conscious of time as well, so we've still got 5 minutes. So the second last thing I want to touch on is the predictive care guidance. This is mainly around if you want to identify febrile individual, as in the individuals who have, for example, fever, and if they need to be triaged for individual care guidance. So contact-free solution could be developed using AI. Again, you can use vision service, you can use your speed service, and all these services can help you easily identify individuals who need guided care. So that's on a high level, probably won't make any sense, but the only thing I want to touch here is the thermographic cameras. You may have seen these sort of cameras in the airport. Basically, these cameras are trying to identify your body temperature. And if you can identify thermographic images and you can classify who has a fever or who doesn't have a fever. That's on a high level what they're doing it. But again, there's a technology underpinning the solution. And this is the whole solution around it, how you would do it. And here you have, for example, edge device with thermographic camera. That's the device. I talked about camera. It's probably running Azure Video Analyzer on top of it. And it's sending this data to IoT Hub, or IoT Hub is an IoT service in Azure which captures all IoT tiny data. And you can process around it. So this basically all data gets captured in here. From there on, you can basically run into your predictive care model around it, in what the risk model is. And this sign probably some of people may know, this is Kubernetes sign, which is used around most of the organizations in the world these days for container-based deployments. And again, you have your data platform set up here. So these here bottom list the four main stages around it. You have to train the model, you have to validate, deploy, and monitor. And if you are more keen to understand around it, ping me and I'll be able to help you out. And Vopara Solutions is another one. So they basically do breast screening and identify for cancer. And they basically reclassify mammographic images and see if you have a cancer, if it's developing or it's not. So it has improved a lot of accuracy around it by using these services. So the last one is around the drug discovery. The whole idea is that once you start using AI services, you would basically, it will help you tally up the data of what your results are. So you don't have to do manually map the data between the two drug codes. You use AI to do it on your behalf. This is some of the trending data map or Gartner research or Forrester research. We've captured how 55% of the science executives cite lack of skilled teams as the key obstacle to digital innovation. And population who will be 60 years old or older by 250 is $2 billion. So you need to work on the drugs to capture that demography of the population. Again, it talks about recontextualizing the clinical trials and the drug discovery and mapping that to the disease you are verifying against. And that's how you would do the optical diagnosis and predict the treatment which needs to be offered to a particular individual. I'll maybe skip some of this. The only part I want to touch on now, before everyone starts dropping off, is the responsible AI. So responsible AI is another initiative within Microsoft. The whole idea is when you are building these AI models, it need to abide by certain principles, and those principles are fairness, transparency, accountability, reliability, privacy and security, and inclusion. So this is there are certain open source data sets which are embedded when you are training your models to ensure that model doesn't skew the result, so that it doesn't skew the results that people who are, let's say, who are black in United States tend to do certain crimes, for example. So that is completely a skewed model. We want model to be fair across all and equitable across all the geography units. Similarly, we have privacy and security and inclusion. So this is something which you should also think about when you're thinking about AI. Like I said, open source data sets are available for you to train your model on, if you are going to train your model on, to make sure it's follow the responsible AI principles. And that's it from my side. Thank you, everyone. I hope you have enjoyed it.
Thanks, Anshul. Thanks.
No problem.
So I think there is no more queries in the chat box. So
No
is there
more.
any
Come
query from
on.
the
There's got to
participant
be
side?
some.
Is there any query from the participant side? Okay. Thank you so much, sir, for
No
enlightening us
worries.
with such crucial and essential pieces of information. So I think you have given us a lot to deep dive into artificial intelligence technologies.
I
And I
think
think with
so.
a great ease, you have apprised us with Azure technology, cognitive search, and I think Microsoft services that they are providing. So thank you so much, sir, for sharing your knowledge and research experience with the research community. So it will be very
Not
useful
a
for
problem.
us. Thank
Not
you.
a
Thank you so
problem.
much, sir. Thank you. So I
Thanks,
humbly
everyone.
request, thanks to you, sir. So I humbly request all the participants to kindly turn on their cameras. Thank you so much, everyone. Thank you so much, sir. Thank you.
Thanks. Bye
So
bye.
now the another session will be on 2:30 p.m. So it's a 1 hour break. So I humbly request all the participants to kindly join the session by 2:30 p.m. Thank you.